Okay, tonight's notes are ionic bonds and ionic compounds. Okay, ionic bonds involve the transfer of electrons. A compound that contains ionic bonds is called an ionic compound. Binary ionic compounds are made with a cation, which is a metal, okay, and an anion, which is a nonmetal. Okay, let's look at sodium and chlorine. Now, sodium has one valence electron, and chlorine has 7. Now, sodium wants to get rid of its one valence electron, and chlorine would like to pick up one. So basically, sodium is just going to transfer it over there and give it up. Sodium now is very happy because it has a full valence shell, the one underneath. And chlorine now has 8 electrons in its valence shell. So it's very happy. So, oops. Guess I should stop erasing or writing stuff. So sodium transfers its one valence electron to chlorine. It's as simple as that. Next, let's look at magnesium and chlorine. Now, magnesium has 2 valence electrons. So along comes a chlorine atom. Now remember, chlorine only wants one of them. So it takes that one. But then this other magnesium's like, excuse me, I still need to get rid of my electron here. So then another chlorine atom comes along and says, oh, I'll take that off your hands. And when they do that, they form a compound, and it's MgCl2. So it takes 2 chlorine atoms to accept electrons from magnesium, because it has 2 to give away, and as I said, chlorine only wants 1. Okay, so let's look at aluminum and oxygen. Same kind of thing goes on with aluminum. Aluminum has 3. Okay, so along comes an oxygen and says, hey, I'll take 2 of those electrons off your hands. And the aluminum's like, I still have 1 more to get rid of, please. So along comes another. I'm going to draw it like this. Another oxygen. So it gives it up there. Now oxygen's like, any more aluminum out there? Because I really need another electron. So then you have another aluminum with 3 electrons. So it gives that one away. And now this aluminum's like, I still have 2 more. So then another oxygen comes along. And it's like, oh, I'll take those 2. And when all is said and done, you have a compound made with 2 aluminums and 3 oxygens. Now, have you noticed something? Every time I've been writing these formulas, I've been writing the metal or the cation first, because in an ionic formula, the cation is always written first. So always write the thing that's got the positive charge first. Okay, let's look back down again at the aluminum and oxygen. Now if you'll 2 aluminums, okay, it took 2 of these and 3 of these. And that's because you have the number of pluses and minuses have to equal out. So it takes 2 aluminums to balance out 3 oxygens. When you add up the charges, you get -6. Now, do you really want to spend all that time doing the dots, doing the electron dot diagrams, and transferring the electrons over? I don't know about you, but that kind of takes a while, and I don't like to do stuff like that. There is a shortcut method. Okay? We can take the formula, and we're actually going to switch the numbers. So we're going to take this, and crisscross it over to here, and this one, and crisscross it there. So now we have Al2O3, and that's exactly what we had gotten in our last problem. So you're just crisscrossing the numbers down. Okay, let's try with calcium and oxygen. Okay, now calcium has a +2. Okay, so we're going to crisscross the 2 down. But oxygen also has a 2. So we have something like Ca2O2. Now, really, if you look at the electron dot diagram, I mean, it takes one oxygen to take the 2 electrons from the calcium. So really, you know, you only need one of each. Okay? That's all it is. So when you have two of the same, when both numbers are the same, so it's two of the same charges as far as number-wise, obviously they're opposite signs, they can just be dropped because you only need one of each. Okay, now ionic formulas are written as smallest whole number ratios of each atom. So if we look at this, the lead 4, now the 4 in the lead, actually let's go to a green. The 4 in the lead here, this means +4. That tells us the charge. So that's how I know that lead has a +4 charge. Now it's going to cross over and we get Pb2O4. Well, that's not the smallest whole number ratio. And if we were to actually do and I'll show you the electrons in a second, we're going to divide it by 2 and we're going to get PbO2. Just like this. We have Pb here with 4 electrons. Oxygen here has it 6. So 2 electrons go there, and those 2, okay? So we got 2 electrons there. Then we have another oxygen. So if you look, it takes 1 lead and 2 oxygens to take care of the electrons. Okay? Tomorrow we will be doing some more work with this. I'll try to explain some more. If you have any questions, we'll probably do a warm-up. But otherwise, have a good night. Bye.